Hi, my name is Ian. I am an engineer. I've done some business. I had been pretty down about the lack of big solutions to address climate change until I started learning more about developments in green ammonia tech. Today, we're looking at a breakthrough in energy storage, turning surplus renewable power into green ammonia. Tristan Deven, principal engineer of Aspire project, explains what makes Aspire notable is its ability to produce ammonia at variable rates and its readiness for scalability in industry. Aspire is not just a technical achievement, it is a practical solution that can transform unused wind energy from a challenge into a valuable resource. The Aspire project is proving several next-generation technologies. It produces green hydrogen from water using renewable energy. Its modular ammonia synthesis operates at lower temperatures and pressures than traditional industrial methods. Most importantly, it is fully integrated with wind and solar, providing a scalable, carbon-free proof of concept. A major hurdle for green energy is that renewables are intermittent, while traditional ammonia plants usually need to run 24/7. Aspire is testing a more flexible model, a system that can ramp production up or down based on wind availability. This transforms ammonia production into a flexible demand that can soak up excess power. Wind energy, and particularly offshore wind energy, is increasing its share of generation on the UK grid, but in 2024, 1/10 of all generated wind energy was not utilized and effectively wasted. Aspire aims to operate during periods of low electricity demand and high wind energy generation, producing ammonia with cheap renewable energy inputs. It sounds counterintuitive, but having too much wind and solar can be a problem. When electricity supply outpaces demand, power prices crash, sometimes even falling below zero. And that distorts market signals in ways that can slow future renewable investment. The core issue is that intermittent renewables flood the grid at certain hours, but the market design was built for dispatchable fossil systems. When supply overwhelms demand, the economics of both existing and future green projects become unstable. We saw this play out in California's energy market. This graph shows that during midday solar oversupply, prices collapse into negative territory. We need a way to capture that red zone on the graph and turn it into something valuable. So, what do we do with that surplus? We need price-responsive demand. While batteries and data centers are great options, Aspire introduces a third, converting that electricity into ammonia to be used as a green fuel. How does ammonia stack up against traditional fuels? To compare them fairly, we look at energy equivalence. 1 ton of ammonia contains the energy equivalent of 516 liters of diesel. If we can produce ammonia at $500 per ton, the cost per energy equivalent liter is roughly 97 cents, putting it right in the competitive range of current diesel market prices. To hit that $500 target, we need electricity prices to stay between $40 and $50 per megawatt hour. As you can see in this table, solar and wind are already in or near that range because renewable rates often fall below $40 during oversupply. A flexible plant that only runs during those low price periods can significantly lower costs. There is a trade-off, however. Green ammonia plants have high upfront equipment costs. If a plant only runs 50% of the time to catch low energy prices, the effective capital cost per ton doubles from $100 to $200. However, since electricity is the single largest cost driver, operating part-time during low-rate periods can still be the most profitable path. This table illustrates the relationship between green ammonia costs and power prices. It takes about 10 to 12 megawatt hours to produce 1 ton of ammonia. If power costs $30 per megawatt hour, the electricity input cost for a ton is around $300 to $360. This confirms that the average electricity price must stay under $50 for the fuel to remain affordable. Is there enough cheap time to make this work? Data shows that in Ontario, prices are below the target threshold 45% of the time. In California, it's 30%, and in Australia, 25%. Depending on where you are, the economics could work brilliantly. In summary, while surplus renewable power currently creates market challenges, Aspire demonstrates a solution. By turning intermittent excess electricity into green ammonia, we create a win-win. We support green power prices and produce an affordable, carbon-free fuel for the future.